Alrighty, well, welcome to second recitation for week 4. I figure today I'll just go through and do the midterm exam so you can see where you went wrong. Let's, I guess, take a look. So first question should have been pretty standard. Just do some basic vector calculation. So 3a minus 2b, well, what? 3a is going to be 12, 0, 9. Minus 2b. 2b is going to be 4, 6, negative 2. So it looks like we get the vector 8, negative 6, 11. All right. And then the length of vector A is going to be the square root of 4 squared plus 0 squared plus 3 squared, which is 25 square root, so 5. A dot B is going to be what? 4 times 2 plus 0 times 3 plus 3 times minus 1. So what? 8 minus 3 is 5. And then A cross B, so 4, 0, 3 cross 2, 3 minus 1. This cross product looks like it's going to be what? 0 minus 9 is negative 9. 6 minus negative 4 is 10. And then 12 minus 0 is 12. So negative 9, 10, 12. And there we go. So hopefully not too many issues on that one. Find a vector in the same direction as this given vector, but length 7. So we're going to need to stretch it by a factor of 7, but divide by its length. And then times 2 minus 1, 6. So multiplying by 7 is just going to stretch it by 7, not necessarily make it into length 7. So I guess you could think about this as a two-step process, that first you're sort of dividing by its length to make a unit vector, and then you're stretching that length 1 vector by 7 to get a vector of length 7. And so anyway, what does this end up being? It's going to be what? 7 over square root of 41 times 2 minus 1, 6. And so I guess that's this last answer choice here. All right. Next question. Vector projection of A onto B. So to project onto B of A, the way I like to remember it is it's going to be B whose length is in the denominator, because we're going A onto B. So A dot B over length B squared times vector B. And so these are the same, oh no, so these are new vectors, so whatever. This dot product ends up being what? Negative 9 plus 0 plus 2. The length of B squared is going to be what? Square root of 3 squared plus 0 squared plus 1 squared squared, and then times vector B, 3, 0, 1. So what? Negative 7/10 times 3, 0, 1. And yeah, looks like this first answer choice here. All right. Just be careful. I think one of these might have been B onto A. You have to be careful you're projecting onto the right vector. But anyway, there we go. Next question. Find the angle between these vectors. Note they're the same vectors from question 3. So we could use a little bit of work recycled. So remember, we know that the dot product is the product of the lengths times cosine theta. So basically theta is inverse cosine, or arc cosine, however you want to write it, of A dot B over length A, length B. And so, yeah, these are the same vectors from the previous part. We already did the dot product in question 3. So that's what? The dot product was -7. And then we didn't calculate the length of vector A, but what is that? 9 plus 1 plus, so square root of 14. And then we did do the length of vector B was square root of 10. And so, yeah, there we go. I guess it's written a little slightly differently, but no big deal. And there we go. Next question, find values of x so that these vectors are orthogonal. So orthogonal, remember, is just a fancy way of saying perpendicular, which means that the dot product is 0. That's our characterization of perpendicular vectors. So we set x1 minus 2 dot 1 x squared 6 equal to 0. We do this dot product, we get x plus x squared minus 12 equals 0, which you could factor to x plus 4, x minus 3 equals 0, so -4 and 3 are our two values. And then find values of x, if any, such that these vectors are parallel. And so there's a few ways you could see that this actually won't work. That to go from x to 1, we're dividing by x, but going from 1 to x squared, we're multiplying by, well, okay, I guess, yeah, well, I guess maybe let's just look at this one. So if the vectors are parallel, we know that one vector is a scalar multiple times the other. So like basically, the only way this is going to work is if I write it like this, I need x1 minus 2 to be equal to -1/3 times 1x squared 6, right? That the k component has to go from 6 to -2. So that has to be how that works. Okay, and then so what is that going to tell us about x? Basically, x would have to be -1/3 for the first equation to work, but then 1 would have to be minus x squared over 3, and that can't be both true, right? Because if x is -1/3, then we're looking at, what, -1/27 equals 1, so that doesn't work. The other way you could see that is a cross product being 0 is our characteristic of parallel vectors. And so if you go and do this cross product, the third component is what? 6 minus -x squared. So we'd need 6 plus x squared to be the 0 vector for this to work out. And, well, sorry, we need this vector to be the 0 vector, which means we need 6 plus x squared to be 0, which, you know, that's never going to be 0. So basically, yeah, there's no way to make these two vectors parallel. All right. Find the area of a triangle. So yeah, we're just pretty standard question. Take half the length of the cross product. And you could use PQ and PR, you could do PQ and QR. Through the magic of cross products, as long as you're taking two displacement vectors here, you should get the correct thing. So anyway, it looks like PQ is what? 3, 0, -1. Looks like PR is what? 2, -1, -1. So PQ cross PR is what? -1, -2 minus -3 is 1, and then -3. And so, yeah, the length of that vector is square root of 11, and so therefore 1/2 square root of 11. All right, question 8. Find the parallelepiped volume with adjacent edges PQ, PR, PS. So that's the scalar triple product. So you could do PQ dot PR cross PS, It turns out that, remember, there's that cyclical identity for the scalar triple product, so you can actually save a little bit of time and do this as the length of PS dotted with PQ cross PR. The advantage of doing it like that is that we just calculated PQ cross PR in the previous question. So we're going to do the absolute value of, well, what's PS? PS is going to be 9, -5, 2. And then our cross product from the previous question was -1, 1, -3. And so this dot product then is what? -9 -5 -6. So absolute value of -20 is 20. All right. And yeah, if you didn't notice that, if you didn't remember that cyclical identity, you could have, of course, done PQ dot PR cross PS and gotten the same thing. But anyway, that's that one. So which of the following sets describes the line of intersection of these planes? So with something like this, with it being multiple choice, there's not much excuse to getting it wrong. Like, I'll solve it as if it were not multiple choice, but then I'll show you that you could pretty clearly you could check your answer and be very confident whether or not you get it right or not. But anyway, line of intersection for a plane to contain a line, the normal vector of the plane has to be perpendicular to the direction vector of the line. And so actually, yeah, this V that we're looking for the line, we want it to be perpendicular to the normal vector for the first plane. We want it to be perpendicular to the normal vector of the second plane. So basically, we're going to use N1 cross N2 as V. So N1 cross N2 is 1, 1, 1 cross 2, -1, 4. I look at the coefficients of my x, y, and z on these plane equations to get the normal vectors. I do this cross product to get what? 4 minus -1 is 5. 2 minus 4 is -2. -1 minus 2 is -3. So that's our direction vector for the line. Now we need a point. So you might not have found the same point, but if you look for the point where z equals 0, then I'm looking at the system of equations x plus y equals 5 and 2x minus y equals 1. And so you could add those equations together to get 3x equals 6, so that x equals 2, and then y is going to have to be 3. So anyway, somehow you can get a point, 2, 3, 0. And so the line containing the point 2, 3, 0 with direction 5, -2, -3 looks like this choice here. Make sure you're doing a line equation, not a plane equation. Okay, and then I mentioned that you could also just check this stuff. Because remember, the whole idea is that if this is the line of intersection of these planes, this line equation has to work in both planes. So like you could check that, well, does 2 plus 5t plus 3 minus 2t minus 3t, does that equal 5? And so yeah, looks like it does. And then you could check the other equation. Does 2 times x minus y plus 4z, does that equal 1? And so yeah, 10t plus 2t is 12t minus 12t. Yep, the t's cancel out. And yeah, there you go. So, I mean, you could, because this is multiple choice, you could always check the choices. That's something you're allowed to do. You can employ different strategies compared to if it were free response. But either way, by plugging in the potential line equations, you'll see which ones work, which ones don't in the given planes. So that's that. So then questions 10 through 12 all deal with these two lines. So the point of intersection of these two lines, we need x to match up. So we need 2 minus t to be 1 plus 3s. We need y's to match up. So we need that. And then finally, we need z's to match up. So we need 1 plus t to equal 2 minus 3s. Okay, and then you solve this system of equations however you like. We can call them 1, 2, and 3. If I do equation 2 minus 4 times equation 1, that's going to eliminate my t's. So negative 3 minus 8 is negative 11. And then this is going to be what? 5s minus 12s is negative 7s. Sorry, I'm running out of room. Let's move this over. Negative 7s minus 4. So if you play around with that, you're going to get that s is 1. And then from there, you will see that t has to be negative 2. And so you plug that in to all three, and you can confirm that, yeah, it does in fact work in the third equation. But what? If s is 1, yeah, let's just plug that in. So if s is 1, we get 4, 5, negative 1. And then if you plug t equals negative 2 into the L1 equation, you'll get 4, 5, negative 1. Yeah, so again, like first you'll get x and y if you focus on equations 1 and 2, and then whether or not it's intersecting or skew is determined by whether or not the third equation matches. We told you it intersected, so we pretty much knew that that was going to work out. But yeah, s equals 1 on L2 is the same point as t equals negative 2 on L1. So what is the acute angle of intersection of these two lines? So I guess this is a slightly different question than if we just gave you two vectors. I guess like the previous, one of the questions earlier on this test was the angle between two vectors. It ended up being the situation where the vectors were at an obtuse angle. But with these two lines, we really wanted the acute angle between the lines. So actually we're going to do, I guess, inverse cosine of the absolute value of the two directions. So V1 and V2, we'll call those the directions of the lines. And we want an acute angle, so we need to take inverse cosine of a positive number. We didn't even have the negative as a choice here, so that's not super important. But either way, we do this calculation. So what? V1 is negative 1, negative 4, 1. So absolute value of negative 1, negative 4, 1, dot product 3, 5, negative 3, all over square root of I guess 18 times the square root of what? 25 plus 9 is 43. Okay, so we do this dot product, we get what? Negative 3 minus 20 is negative 23, minus 3 is negative 26, so absolute value is going to give us 26. And then square root of 18 you could write as what? 3 times the square root of 2 times the square root of 43, which you could write that as square root 86, so it looks like we're dealing with that choice. All right. Which of the following planes contain these two lines? So again, if you have lines that intersect and you know their directions are V1 and V2, then the cross product of V1 and V2 can be the normal vector of the plane that contains these two lines. So we should cross those directions. So this is what? Negative 1, negative 4, 1 was our first vector, and then 3, 5, negative 3 was our second vector. We take that cross product, we get what? We get 12 minus 5 is 7. We get 3 minus 3 is 0. And then we get negative 5 minus negative 12 is positive 7, which that's parallel to the vector 1, 0, 1. And then we need a point. We could use any point we want. For example, we already found the intersection point. But you could use any point on either of the lines. So for example, if I just do t equals 0 on L1, I get 2, negative 3, 1, for example. So yeah, any point on either line is going to work, but then I plug that into the plane equation. So 1 times x minus 2 plus 0 times y plus 3 plus 1 times z minus 1 equals 0. So then if you rearrange that, you'll get x plus z equals 3. And so again, this is one of those situations where that's what we would have to do if this were free response. But since it's multiple choice, you could just kind of check, like, okay, so check, for L1, does x plus z equal 3? Well, yeah, because I get the t's cancel out, so that works. For L2, does x plus z equal 3? Well, yes, the s's cancel out, so there we go. So felt a little bit bad having 3 and negative 3 here, but since this is the type of thing where you could easily check your work, make sure you take advantage of that when you can. So there we go. Are the following two lines parallel, skew, or intersecting? So we're going to go about the same process we did when we were looking for the intersection point for question 10. We need x, y, and z to match up, so we need to find a solution to all this. Okay, so I guess first of all, it's not parallel because the vectors for these lines, 3, negative 4, 1, and negative 1, 2, 7 are clearly not parallel vectors, right? If I go from here to here, I'm dividing by negative 3, which isn't the case for the other components. So hopefully you guys are comfortable looking at vectors and knowing whether or not they're parallel pretty quickly. But yeah, these aren't, so these lines aren't parallel. Okay, and then I guess we need to solve this system. And yeah, so what can we do? We could do 2 times equation 1 plus equation 2 to cancel out the s's. So what? That's going to be 4 plus 2t equals 5. So t equals 1/2. I plug that into equation 1. So I get what? 3.5 equals 1 minus s, so s is negative 5/2. So that's the solution to equations 1 and 2. If I check that in equation 3, is 2 plus 1/2 equal to 7 times negative 5/2? And the answer is no. So there's no solution to all 3 equations, which means that the lines are skew by definition. So if equation 3 had matched up, sort of like what happened in question 10, we would have had intersecting lines, but we don't. All right, distance from point to a plane. It's up to you if you want to draw the picture with the projection, but we could use the formula in the book. I think that's everyone's preferred way of solving this. So the formula in the book, distance point to a plane, is absolute value of ax1 plus by1 plus cz1 plus d, all over the square root of a squared plus b squared plus c squared. And so it looks like a is 6, times x1 plus 3y1 plus 2z1. Be careful, you have to put it in the form ax plus by plus cz plus d equals 0. So for this plane, d is negative 26. So what? We have 12 minus 14 is negative 2 minus 26 is negative 28. Absolute value of negative 28, of course, is 28. And then 36 plus 9 plus 4 is square root of 49, which is 7. So the answer then is 4. And then next question, find the radius and center of this sphere. This is going to be completing the square. So what? X squared minus 4x plus 4 plus y squared plus z squared plus 14z plus 49. On the other side, I'll subtract 49, and then I will also add my 4 and my 49 that I did on the left. So when I go to complete the square, I'll have what? X minus 2 squared plus y squared plus z plus 7 squared equals 4. So the radius is 2, and the center is 2, 0, minus 7. All right. Then question 16, distance from the sphere to this plane. So this in general is a very complicated question, and there are calculus ways to solve this, but it's a little bit beyond the scope of this course to use calculus for this. We will discuss it. It's actually going to be a two-constraint Lagrange multiplier if you want to use calculus. But instead, we're going to need to use the geometry of this situation. So it says we have this hint going on that this is the same plane from question 14 and the same sphere from question 15. So, okay. And we look around. Okay, so question 14 was 2, 0, minus 7 to this plane. Notice that that's actually the center of the sphere in question 15. So whatever, it looks like a lot of stuff is pretty related here. So the picture you want to have in mind is you have our plane, we have our point 2, 0, minus 7, and this is what, 6x plus 3y, whatever that was, plus 2z equals 26. So, all right, in question 14, you saw that this distance was 4. That to get from the point to the plane, that was 4 away. In question 15, you determined that this sphere that we're talking about is radius 2. So basically, in question 16, they're asking for the distance from the sphere to the plane. If you think about it, it's just going to be the distance from the center to the plane minus the radius, so 4 minus 2 is 2. That was probably the trickiest question on this test. But hopefully some of you saw the hint read the hint that it said that, yeah, 14, 15, and 16 are somehow related. So if you start to think about the picture in your head, distance from sphere to a plane, and then it turns out we already calculated the distance from the center of the sphere to the plane, and we got that that was 4. That's how that worked out. All right, and then these matching ones. So hint, it says note all these equation choices are the same. So we could just look at these equation choices and figure out what's going on here. So this, notice x isn't squared, and y squared and z squared have the same sign coefficient. So this is an elliptic paraboloid, that first equation. Okay, so what else do we have here? In this one, z isn't squared. And then x squared and y squared have opposite sign coefficient. So that's the characteristic of the hyperbolic paraboloid. Okay, and then all these others, it looks like x squared, y squared, or yeah, x, they're all squared and they don't have the same sign coefficient. And so with those, I don't like to try and memorize what they correspond to. I like to look at the different traces. So for example, for this equation, I'll do the x equals k traces because x is sort of the odd variable. It has the different sign compared to the others. So y squared plus z squared is 1 plus k squared, and so that is always at least 1, which means that it's not missing any of the cross sections, and therefore this is actually the one-sheet hyperboloid. Okay, and then let's look at one of these other equations. If I have x squared minus y squared minus z squared equals 1, if I do the x equals k traces and rearrange this, this is going to be y squared plus z squared equals k squared minus 1, which is going to miss some traces, right? If k is between minus 1 and 1, k squared minus 1 is negative, so there's no cross sections for that range. But if k is bigger than 1 or k is less than negative 1, then you get a circle. And so whatever, that's the two-sheet hyperboloid. And then finally, if I do the x equals k traces for this equation, that would be y squared plus z squared equals k squared. So if k is equal to 0, it's a point. If k is not equal to 0, it's circles. And so that's the situation for a cone. And so anyway, now we could just look. So this first picture is the one-sheet hyperboloid. This is our elliptic paraboloid. So x minus y squared minus z squared is 1. This one is our two-sheet hyperboloid, which we decided was x squared minus y squared minus z squared is 1. And then this is our hyperbolic paraboloid, where that was z isn't squared, x and y, x squared, y squared have opposite sign coefficients. So anyway, that's how you do those. I guess I can write here, this is always circles. All right, and then find the equation for the surface consisting of points equidistant from the plane z equals 3 and the z-axis. So I think this is the other sort of trickiest question on this exam, but I can't remember if we put this on the quiz or not for quiz 2. If not, it was definitely on the homework, something pretty much exactly like this. So anyway. And I think I remember going over one of these in recitation for that week. Yeah, so anyway, we have points equidistant from the plane z equals 3 and the z-axis. So let's say I have a point x, y, z, and I want to know how far it is from the plane z equals 3. You could use the distance from a point to a plane formula that we used a little while ago to get this answer, but I think visually you can see it. The fact that this plane z equals 3 is horizontal, essentially we were looking for the point directly below xyz that lives on z equals 3, so xy3. And so then this distance here ends up being the absolute value of z minus 3. Right, if you do the distance between xyz and xy3, you'll get the square root of z minus 3 squared, which ends up being absolute value of z minus 3. Okay, and then the point on the z-axis closest to xyz is going to be 0, 0, z. That, like, if you change z, all these other points are farther away. That the closest point on the z-axis to z equals to xyz is going to be the point 0, 0, z. And so then you can calculate that this distance, you use the distance formula between points, is the square root of x squared plus y squared. So we want points whose distance to the z equals 3 plane is equal to the distance to the z-axis, which then you could square both sides to get this cone equation. We didn't ask you for what it was, but yeah, it turns out you get this cone that has its vertex at 0, 0, 3. But that's the idea there. Just interpret this distance sentence into an equation and go from there. But that, like I said, probably along with the distance between the sphere and the plane, 2 trickiest questions on this test. All right, question 22. Which of the following vector equations gives the entire curve of intersection? So as soon as you see a circular cylinder, we know that we want to use cosines and sines to trace out the entire thing. So z is 2 sine t can take care of that. And then you just solve for x. It's not so bad. So this looks like it's the correct answer. So yeah, x would then be 5 minus 2y minus 3z. And so plug in 2 cosine t, 2 sine t to get that. Cosine squared and sine squared, we just don't want. That just straight up does not work. Cosine 2t, sine 2t, when you do y squared plus z squared, you'll get 1, so that doesn't work. This doesn't work. So this other choice is sort of half correct. Because it does give us some of this. It satisfies both equations, but what you've done is you've forced z to be positive, which means that you're actually only getting half of this curve, and so that's why we really emphasize this entire here. And I think the quiz question was similar for quiz 3. So anyway, that's that. Find parametric equations for the tangent line. So we need to figure out which value of t gives us this point. So it's t equals 2. And so I need r prime of 2, but I first need to get r prime of t. And I get r prime of 2 is 1, 4, 12. And so yeah, I do the line through the point 2, 4, 8 and direction 1, 4, 12. Which looks like this right here. So 2 plus t, 4 plus 4t, 8 plus 12t. I don't remember, but a lot of people missed this one. I was not too happy about that. This is a very standard question. Should not have been a surprise that it turned up. So be careful, don't make silly little mistakes. Curves intersect at this point, find the angle of intersection. So this is another sort of little tricky question, but it was also on the homework. If you have 2 curves that intersect, it's the angle between the tangent vectors that's going to give you the angle between the curves. So they intersect at the point 1, 1, 1. Notice that 1, 1, 1 is R1 of 1 and R2 of 0. So you have to figure out which t and s values for R1 and 2 spit out 1, 1, 1. But without too much trouble, you get that, yeah, it's t equals 1 and s equals 0. So essentially, we're finding the angle between R1 prime of 1 and R2 prime of 0. So R1 prime is what? 1, 2t, 3t squared. R1 prime of 1 is 1, 2, 3. R2 prime is what? 2, 3, 1. Well, so R2 prime of 0, nothing too exciting happens when we plug that in. And so, yeah, we got to find the angle between those vectors. You do the dot product, which is what? 2 plus 6 plus 3 is 11 over the product of the lengths. They're both square root 14 as the length. And so, yeah, find the angle between those two vectors, just like you did earlier on this test. And you get that. Which of the following is the length of the part of the curve between those 2 points? So arc length, remember, is an integral of the length of r prime of t. So this is the same r that we dealt with before, but whatever, it takes 2 seconds to take the derivative. So we're doing the integral of 1 plus 2t squared, which is 4t squared, plus 3t squared squared, so 9t to the 4th. And then, I mean, at that stage, it's pretty clear that it has to be that, but you can figure out that that corresponds to t equals 1 and t equals 3, so those are your limits of integration. Question 26, consider the speed of the particle is a decreasing function of time, true, false. So that's, speed is the length of r prime t, which we calculated was the square root of 1 plus 4t squared plus 9t to the 4th. It's pretty clear that that's an increasing function. As t increases, that gets bigger, so therefore false. The particle is actually speeding up. Its speed is increasing with respect to time. All right, calculate the curvature at the point 248. So, okay, again, this is t equals 2. Figure that out. So curvature, there's the 2 formulas, but this one, we already see that the speed is non-constant for this curve. And so we want to use the cross product curvature formula. So basically the curvature at t equals 2 is what we're after. So we'll calculate it by doing the length of r prime of 2 cross r double prime of 2 all over the length of r prime of 2 cubed. So that's our curvature formula. So what? R prime is 1, 2t, 3t squared. R double prime is 0, 2, 6t. R prime at 2 is 1, 4, 12. R double prime of 2 is 0, 2, 12. This cross product is what? 48 minus 24 is 24. 0 minus 12 is negative 12. And then 2, which I'll write that as twice times 12 minus 6, 1. And therefore the length of r prime cross r double prime is twice the length of that. So that's 144 plus 36 plus 1. So 2 times the square root of 181. Then the length of r prime of 2 is what? 144 plus 6t plus 1 is square root 161. And so therefore we get that. Okay. Find the osculating point. So osculating plane, remember, is the plane that contains the direction of motion and the direction of turning. So it's the kissing plane, is the Latin root of the word osculate. And so anyway, we're going to want to use the unit binormal vector as the normal vector of the osculating plane. So I guess this point is t equals pi over 2 pretty clearly. So yeah, we could go through and do that. So what? R prime is minus 2 sine 2t, 1, 2 cosine 2t. T is then r prime normalized is what? Negative 2 sine 2t, 1, 2 cosine 2t, all over. If you do the length of that and hit the Pythagorean theorem, it's length square root of 5. And so then n is t prime normalized is going to end up being, well, t prime is going to be what? -4 cosine 2t, 0, -4 sine 2t. I still have the over root 5 in the denominator. Then the length of that is going to be, what, 4 over root 5. And so I'm running a little bit short on space. Maybe I'll go do it down here. So it looks like t of pi over 2 is 0, 1. Cosine of pi is -1. So 0, 1, -2 over root 5. And then n of pi over 2 is, well, -4 times cosine of pi is +4. So 4 over root 5. Yeah, I think it's just I, actually. 1, 0, 0. If you carefully go through, yeah. It's got to be a unit vector. So b of pi over 2 is t of pi over 2 cross n of pi over 2, which ends up being what? 0, 0, -2 minus 0. So -2, so sorry, -0, -2, -1 over square root of 5 when you do that cross product. And so you could just do 0, 2, 1. If you plug in, yeah, this is the only plane that has the appropriate normal vector. But yeah, go through that. Use 0, 2, 1 as the normal vector. So you'd have 0 times x minus -1 plus 2 times y minus pi over 2 plus 1 times z minus 0 equals 0. And so, yeah, you get 2y plus z equals pi. All right, and then last question, particle-wise acceleration, given by that. Find the position. So a lot of people miss this. I think we were just being sloppy with everything being 0 at 0. Again, this is a type of question that you could pretty quickly check. So if I plug in r of 0, I want that to be 1, 0, 1. So this one, because e to the 0 is 1, when I plug in t equals 0, I do get, yeah, 0 for that. The fourth minus a fourth, 1, 0, 1. So the only, that works for that. This one doesn't. 1, 0, 1. Yeah, that one doesn't. Right? The middle component is equal to 4 when t is 0. The middle component's 4 at t equals 0. Middle component's 1/4. So honestly, yeah, the only one of these choices that has r of 0 equals 1, 0, 1 is that first choice here. So if there is a correct answer, then that's got to be it. But I guess we should go through it and actually do it. So for example, you could do v of t is v of 0 plus the integral from 0 to t of a of u du. So v of 0 we told you was supposed to be 2, 3, 1. So 2, 3, 1 plus, if you do the antiderivative of acceleration, you'll get minus cosine of 2u over 2. You'll get e to the 2u over 2. And then what? U? Plug in between 0 and t to get what? 2 minus cosine of 2t over 2 plus a half, 3 plus e to the 2t over 2 minus a half, and then t plus 1. So again, be careful. Not everything is 0 at 0. So I think a lot of you probably were missing out on these. And then you do the same kind of thing, that r of t is going to be r of 0 plus the integral from 0 to t of the velocity function. So r of 0 we told you was supposed to be 1, 0, 1. And then antiderivative of that is going to be what? 5 halves u minus sine of 2u over 4. 5 halves u plus e to the 2u over 4. And then u squared over 2 plus u. Evaluate that between 0 and t. And so you'll get 1 plus 5 halves t minus sine 2t over 4. 5 halves t plus e to the 2t over 4 minus a fourth. Be careful, e to the 0 is 0. And then finally 1 plus t squared over 2 plus t. And presumably that's, well, hopefully I didn't mess up. Yep, that's correct. So again, you should be able to do all these questions as if they weren't multiple choice, but you can sometimes, use the form of the test to your advantage. Obviously, that's allowed. So, yeah, for something like that, just turns out that, yeah, only one of the choices had the appropriate initial position, so that was good. Yeah, but that's the midterm. I'll post this up on Canvas. Let me know if you want to talk about any more of these next week, but I guess that's about it for today. And so, yeah, enjoy your weekend and see you next week.